This is an example from Module 4 in Math 1530. The average time spent sleeping in hours for a group of medical residents at a hospital can be approximated by the normal distribution, with a mean of 5.6 hours and a standard deviation of 1 hour. What is the shortest time spent sleeping that would still place a resident in the top 5% of sleeping times? So a medical resident who is in the top 5% of sleeping times is going to be getting more sleep than 95% of the other medical residents. So here we know the area to the left of this sleeping time would be 95% or 0.95. We know the mean and we know the standard deviation. So we can use the inverse norm function on the graphing utility. And whenever you're using this function, you have to put in the area to the left of the x or z that you're trying to find. So we can use the inverse norm feature to find this sleeping time, which I have found is 7.24, but I'm going to walk you through it on how I got it on the calculator. So I go to second distribution, go down to inverse norm, and put in 0.95 for the area to the left. The mean is 5.6, and the standard deviation is 1. Enter, and we see that it's 7.24. So a medical resident who is receiving 7.24 hours of sleep a night is in the top 5%. Okay, the next part of this question is between what two values does the middle 50% of sleeping times lie? So the middle 50%, or the middle 50% of the area under the bell curve, is approximately here. And if I'm looking for those middle sleeping times, then I'm going to have to figure out the area to the left of the lower limit and the area to the left of the upper limit of this middle 50. So as you can see, I've used the inverse norm function to do this. And I can tell that if this is 100% area under the bell curve, and this is 50%, this middle 50 is here, then this lower area would have 25% area to its left. So I can do that on the calculator. I'm going to pull that up. So we go to second distribution, inverse norm, and put in 0.25 for the area to the left, 5.6 for the mean, 1 for standard deviation, hit enter, and we get 4.93 if we round to the nearest hundredth. And then the last part of this is the upper limit of this middle 50%. So the area to the left of it would have 75% area to its left because you've got the middle 50 and the 25% to the area to the left of the middle 50. So that adds to 75%. So we would put that in the function in the calculator, the inverse norm function. So we hit second distribution, inverse norm, 0.75. The mean is 5.6, the standard deviation is 1, hit enter, and that turns out to be 6.27. So a medical resident who's getting between 4.93 hours and 6.27 hours of sleep a night is in the middle 50% of sleeping time. So 50% of the residents are getting between those two values. I hope this example helps everyone. Good luck.